In this video, we will discuss the last type of probability. In this chapter, we call the conditional probability. So let's get started. Okay, conditional. Okay, probability. So what is conditional probability? And what is this difference between conditional probability and the other probability we already learned in the previous video? Well, the word over here tells you everything already, right? It has a condition. So the probability here, the conditional probability is a probability of event, and this event here, okay, the sample space of this event is restricted by the outcome of another event. So let me repeat it. The sample space of the event we do probability is restricted by the outcome, by the occurrence, I can say that, of another event. So the notation for conditional probability of the event of the event restricted by another event is written as P. P represent probability, so we use different color here. So P of event B, okay, restricted by the outcome or the occurrence of event B, of event A, and it has a formula, and this is the formula, which is equal to the ratio of A, event A, intersect event B over probability of event A. Oh, I'm sorry, not probability, the cardinality. I'm sorry. So the cardinality of event A intersecting event B over the cardinality of event B. Okay, of event A. I'm sorry, of event A. Okay, so the event A over here is the event B over here has a condition, and the condition is the event A. It must satisfy the occurrence of event A. Okay, so we're gonna use this formula here to find probability, but in many cases, sometimes you don't have to use this formula. We just use our own logic, and I'm sure that we can find a conditional probability. So actually, there's two different methods. You can use the formula, or we can use the logic. Okay, it's just the common logic. We can find a conditional probability easily. Okay, let me jump into the first example here. So let me see. We have an example. So where's my picture? I think this one. Okay. Okay, so let's see how we solve this example here. So I say that we have two methods, right? We can use this probability here, which is mentioned in the textbook, or we can use the logic. Actually, the logic, the common logic is actually it can also come from the formula, but it's not stated in your textbook at all. But I'm going to give you this formula too. So actually, it's based on a common logic. You can solve the conditional probability by using this formula. So this is the first one, and the second one is probability of B with condition A is the probability of A intersect B over the probability of A. So actually, I wrote this before. Remember, I deleted because in some problem I use it, so I get used to it. So that's why I wrote this formula before and I erased that. But now I want to write it again so that you know that this formula is also true and you can use it. In this first example, I'm gonna do both way. Okay, I'm gonna do this formula and the common my own common logic, which is this formula. Okay, so let's see how we deal with this one. Answer. Let me do this formula first. Okay. So I'm gonna do method one right here. Okay. So part A. So over here we have 52 car deck and we have 5 probability getting a black car, given that the car you will deal is a speed. So you can put the probability. So the condition is here, right here. The black car. Okay, and with the condition is being a speed car. Yeah. Okay. So we need to find a cardinality between two event right here, the black and speed. So black and speed. So totally we have 26 black car, but in the black we have only 13. So the intersection between two events could be 13. Okay. Okay, and we have how many element in this event speed car right here, which is only 13. Also, so the formula will just give you 1. The probability is 1. Okay. Now for part B, I want to find probability getting speed. Okay, but then now we deal with the condition being the black car. Okay, it's a black car right here. Okay, so now again we need to find the intersection between speed and a black. So we have 13 again. We have 13, but we how many black we have? We have 26. So total here we have 1/2. Okay, so that is how you use this formula here. Now I'm gonna go ahead and use the second method, which is my common logic, using this formula. Okay, so again we want to find the probability the black car, speed car. Okay, so we want to find the probability between the intersection between black and speed. So the probability of black and speed at the same time will be so black and speed at the same time we have only 13 of them, right? So 13 over 52, and you divide by the probability of the speed car, so be 13 over 52 also. Okay, so you see that if you do keep chain flip, is you're gonna add up with 13 over 13, will just give you 1. So you see that it's the same thing, and you can do over here. It's probably speed given black. Okay, so how many speed we have? So we have only 13 over 52. 13 over 52. But how many black we have? 26 over 52. So again, you have 13 and up over 26, which is a half. Okay, so you see that you can use this logic or that logic. You see the answer should be the same. Okay. Now, in the next few example, some of them I'm gonna do this with this formula. Some I do both cases, both using both formula, so that you can see the similarity. It turned out to be the same answer, but some students get used to the first formula, some of them get used to the second one. It doesn't matter, it also give you the same answer. Now let me jump into the second example. Okay, so Okay, so in the second example, I have a table like this. Okay, and what is the question? I have the question like that. Okay, okay, so um, let's see how we do this answer. So in this example, I'm gonna just go ahead and use the formula in our text, so which is this one. So the probability, so here has a positive mammogram given as a breast cancer, so probability over here would be positive mammo given that breast cancer. Okay, okay, let's see. So we want to find cardinality between these two event right here. Positive mammo, and breast cancer is we have 720. So the answer will be 720. Cardinality over the cardinality of this event, the breast cancer, the condition. Breast cancer we have 800. So finally we have 720 divided by 800. What could be the answer? We gotta go ahead and put it into the calculator. 720 divided by 800. So it could be 9/10. Yeah, okay. So this is very easy, right? We're gonna give you information over here already. Now we want to find the probability has a breast cancer given is so this is the other way around. So this is probability breast cancer given that we have positive mammo. Okay. Okay, mammo. All right. Again, we're gonna find which one is breast cancer and mammo. So we have 720. Okay. And we're gonna find how many mammo, positive mammo. We have 7664. Okay, let's see how we do that. 720 divided by 7664. So I'll give you 45 over 479. 479. There you go. See? Very easy. Probability. Okay. Okay. Alright, let's do another one. Yeah? I think this one is even easier than the first example because they give you everything already. This is just require you to read the information from the table. Okay, example number 3. Alright, so let's see how we got this. Okay, I have a problem like this. If you roll a die twice, okay, this is problem is harder. Okay, find the probability that the sum of number 8, the sum of number is 8, given that the first number is 3. Okay. So we need to find a sample space now. The sum of numbers is 8, so it could be, I'm gonna say that this is even B. The sum of number is 8. It could be so it could be 1 7, 2 6, 3 3 5, 4 4, 5 3. Okay. 6 2. Okay, 6 2, then 7 1. Okay, okay, yeah. So I don't know if I missed anything. So we have 6. uh I think, yeah, I think it's good. Okay, so that's event B. Now the event A, the condition is the first number is 3, so only 3 5. Yeah, only 3 5, so only one of them, even the first number is 3. All right, now we want to find the probability of event B with with condition being event A. Okay, so let me see, 1 2 3 4 5 6 7. Okay, given the first number is 3, so it will be 7 over 1. Oh, something not right over here. Yeah, because the probability cannot be greater than 1. So I think I calculate something wrong. Um, sum of the number is 8. Okay. So this is okay. Let me write out the formula, because so we don't write out the formula, uh, then easy to get wrong. So we have probability of sum of number 8 and first number is 3. We have only 1. Okay, only 1. And the cardinality of getting the first number 3 will be only 1. So the probability here will be 1. Yeah. Okay. Well, you can use the second method also, but you need to get the sample space, the total sample space, when you roll a die twice. Okay. Okay. Let me see. I can do the second method. So probability to be A. So it will be probability of B intersect A over probability of A. So probability of B intersect A, we have 1 over, because sum is A and first number is 3, so only one of them. 1 over, what is the total? So we run, we roll it twice, so it will be 36, right? Yeah, 36, because the 1 2 3 4 the 6 faces. 6 times 6 is 36. That's the first one. We use the counting principle over there to get the sample space. The total sample, and then over here with probability of getting is we have only 1 over 36 also. So the answer is just 1. See? It should give you the same thing. Okay. I just want to check one more time. It should be okay. Try observe the first step. Find the probability of sum of the numbers 8. Yeah. Even the first number is 3, so there's only one of them. Okay. Yeah. So it should be good. Alright. Alright. Next example number 4. In this example, I need to find something to cover that. Where? Okay, in this example number 4, kind of similar to the previous one, example 3. But now we roll 2 dice. So last time we roll a dice, but we roll twice, but now we roll 2 dice. What is the conditional probability that both dice are number 5? Okay, if it is known that the sum point is divisible by 5, so the sum point divisible by 5, it means that the last digit of the sum number must be 0 or 5, right? So that is going to be, you need to find this the sample space for that element, for that set, and we need to find this the cardinality for this for this event also. So let's see how we do that. Okay, so over here we're gonna find intersection. Okay, so the sum of the sum is divisible by 5. You see, 5 plus 5 is 10. Excuse me. And 10 is divisible by 5, and both dice are number 5, and probability of the set B divisible by 5, this is the condition right here, is, oh no, this is not condition, this is the what we want to find. See, the sum is 5, so we have 7 of them. Then from here we can get it, the cardinality. So if you go ahead and add a little bit here, so you will have this is the cardinality of A intersect B. So there's this set right here, only one element over the cardinality of set B of. So over here they try to change the formula. They put this as B, but that's okay. So this is B. Okay. Last time we put this set as, we name this A, but now they name it B. That's okay. This is the same thing, guys. It's not much different. Okay. So over here they name the conditional event is B, not A. So in previous problem we name it A. All right, so from here we can we get a probability, conditional probability. Now we apply the second method. You see that the second method is also the same thing. See that? So we have the biggest sample space right here, which is 36 of them. So the so the cardinality over here for the sigma event, the total sample space is 36. So by probability, it will be 1 over 36 and 7 over 36. So we set up the ratio. Okay, which is give you 1 over 7. So the answer is set. See that? All right. Now, example number 5. Let's see. Okay. Example number 5. Oh, we have this. Okay, so in the next example number 5 here, it requires you to think a little bit, and we have in this example we see that we have 13 balls, and 5 of them is red and 8 of them is blue, and 2 balls taken out. And the first event is when the first ball is red, and the second event is where we take the second ball as the second event is also red, and we want to calculate the probability of event B restricted by event A. Okay, so let's see how we do that. Okay, right. So, all right. So let's so we have 5 red ball and they're all red. So I'm gonna just go ahead and list all of them out. It's easier for you to understand the problem. So we have red number 1. Okay, so let me use the different color also. So we have red ball 1, red ball 2, red ball 3, red ball 4, red ball 5, and we have a blue ball. So we have blue ball 1, blue ball 2, blue ball 3, 4, 5, 6, 7, and 8. Okay, so we have the ball like that. Now, in order to calculate probability of event B restricted by event A, we apply the formula, right? So probably the cardinality of event of set B intersect set A over cardinality of set A. Okay, and set B intersect set A. It means what? It means that event the first ball is red and the second ball is also red. So we need to figure out how many elements in this set right here. The first ball is red and the second ball is also red. Now, if you see if you look at this on the ball right here, you will see that the pair of red ball will go like this. So the first red ball is this one, right? Then the second red ball, okay, is R2. Then you see that there's another pair like that, 3. Then another pair and another pair. So you see that there's only 4 options that you can pick 2 red ball at the same time. So 1, 2, 3, 4. So it means the intersection. It means picking a red ball the first time and second ball is also red. So the cardinality over here must be 4. Okay. Now we're gonna go ahead and calculate the cardinality of set A, which is the the first ball being red. Okay, the second ball can be blue. So if the second ball can be blue, the first ball red, so it means you have four of them already, right? Then it could be something like this. So the first ball is red and the second ball is blue, but it's still, because that's what it is. The first ball is red only. The set over here, contain only element when you pick the first ball is red. They don't care. It doesn't care about the second ball. Okay, it could be red or blue. So we're gonna go ahead and combine all them. So it could be like that. Okay, so 1, 2, 3, 4, 5, 6. Okay, 7, 8, 9, 10, 11, and 12. So totally, you see that we have totally 12 options to pick the first ball red, and we don't care about the second ball. Okay, so now we set up the ratio, then the probability will be 1 over 3. There you go. Okay, now the probability of B restricted to A, if you use the second formula, which is, I think, in my opinion, it will be harder. It take more time, because in that case you have to find the probability of set B over intersecting by set A. But the thing that in order to find that property, you have to find the total the total sample space of both event. Okay, when we have event A and event B at the same time, so we need to figure out the total element in the sample space. So that will be tough. That will be tough. Okay. Um, yeah. So that's why over here we have to use the first formula. Actually, at this moment, I focus on the first formula. I have figured out the set how to do the second formula yet, because I need to figure out the total the total number of element in the sample space. That's pretty big, because you pick two ball, and the first ball is red, so probably you have to use the counting principle to do that. Yeah, so at this moment I haven't figured out yet. Okay, try to figure it out. Okay, if you have time, go ahead and try to figure it out using the second formula. Let's see if it turn out to be the same or not. But at this time, at this moment, I'm gonna just stick to the first one. Okay. All right. In the example number 6, I have the problem over here already, and this problem over here we already have the solution. So it's similar to what we had last time. So I already print them out over here like this. So so the first event is when we have x and we have only 4x. So you see that in this example 6 here, I use the second method using the probability. So the probability of the first event is 4 over 52. Probability of the second event is 12 over 52, because they're totally 12. B is when a car has speed, and over here a probability of A intersect B. So x and speed, so there's only one of them. Well, I think there are 13 speed, right? In my opinion, because we have x, we have 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we have king and queen jack, so it should be 13 over here, guys. So it's not 12. Okay, it's not 12, so it should be 13 over here. Okay, and intersection is only one of them. So here you have 1 over 13. So probability over here will be 1 over 13. Okay, and the probability here BA will be 4. A over here will be 1 over 4. Okay, it's because even B, when it comes to speed, we have totally 13 speed. I don't think it's 12, right? And let me count again. We have yeah, we have x, we have 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, king. So we have jack spade, king, queen spade, and king spade. So totally 13. It's not 12. Okay. All right. So probability, conditional probability is of course it's harder than the previous one, the basic one, but it's not really that bad. Of course, some problem is harder than the other, and you see that, for example number 5 here, I already give you some higher level problem. But in your my MATLAB, I believe it's not gonna that hard, so it should be very simple and standard. Okay, so I'm gonna stop my video here, and if you have any question or you spot any mistake, please let me know. I don't think I have any mistake, but just in case I have careless mistake, please let me know. Okay, I'll be seeing you next time.